Students, Sairam, this is Megha Miss here, and today we will continue with our revision part 2 for your lesson number 2, periodic classification of elements. Okay students, so we will continue with our revision. Okay, we will start with the structure of modern periodic table. Okay, the first point, the modern periodic table contains 7 horizontal rows called as periods 1 to 7. Okay student. Similarly, 18 vertical columns are the groups 1 to 18. Okay. The arrangement of the periods and groups results in the formation of boxes. Yes students. So now we are learning the modern periodic table. Okay. So the atomic numbers are serially indicated in the upper part of this boxes. So first the scientists all they considered the atomic masses, but in the modern periodic table we are considering the atomic numbers and they are written in the upper part of the boxes. Okay, each box corresponds to a place for one element. One element can be placed in one box. Apart from these 7 rows, 2 separate rows are placed at the bottom of the periodic table. Yes, you have seen a periodic table. So what we call them as? These are called lanthanide series and actinide series respectively. Okay. There are 118 boxes in the periodic table including the 2 series. Okay, it means that there are 118 places for the elements in the modern periodic table. Okay students, so the modern periodic table is now completely filled, means all the 118 elements are now discovered. If you see, all 118 elements are now discovered. Okay, the entire periodic table is divided into 4 blocks, that is S block, P block, D block and F block. Okay, the S block contains the group 1 and 2 elements. Okay, then the groups 13 to 18 constitute the P block elements. The groups 3 to 12 constitute the D block elements. The D block elements we also call them as transition elements. Yes students, you will remember this. The lanthanide and actinide series at the bottom form the F block elements. Okay students, so here you can see, previously also I have shown you this picture of the periodic table. Okay, you can see S block, you can see 1 and 2, this. Okay, I'll just show you. Yes, just a moment. See here, 1 and 2. Okay, then 3 to 12, you can see all the D blocks are there. Okay, and then 13 to 18, again you will see all are under P block, and down you can see the F block, the lanthanide and actinide series. Okay students, I hope till here it is clear to you. Okay, so we will proceed to the next part. Okay, now see here. A zigzag line can be drawn in the P block of the periodic table. Yes, you have seen this, that the metalloids lie along the border of this zigzag line. Okay, all the metals lie on the left hand side of the zigzag line, while you will see that all the non-metals are also on the left and right, like this they are there. Okay, now next we are starting with, that is the groups and electronic configuration. Now what is the students groups and electronic configuration? Valence electron in the elements from the group 1, that is the family of alkali metals, is the same. Means whatever group 1 elements will be there, their valence electrons will be same. Okay, for example, the elements beryllium, magnesium, you can see calcium belong to group 2, that is the family of alkaline earth metals. We call them as the family of alkaline earth metals. There are 2 electrons in their outermost shell. So can you see here, if you see this table, CB 2 2 2. Okay, so last shell you will see that 2 valence electrons are present. Okay students, I hope till here it is clear. Okay, we will proceed. Similarly, there are 7 electrons in the outermost shell of the elements such as fluorine, chlorine from the group 17, that is the family of halogens. So if you see the family of halogens, we are talking about this family. Okay, you can see 7 7, all 7 electrons will be there. Okay, while going from top to bottom within the group, one electronic shell gets added at a time. If you see from up to down, means for example here only we'll see beryllium, magnesium, you see beryllium 2 shells, magnesium 3 shells, calcium 4 shells. So like this one shell gets added at a time. Okay students, so we'll proceed. I hope till here it's clear. Okay. So from this we can say that the electronic configuration of the outermost shell is the characteristic of a particular group. Yes. However, as we go down a group, the number of shells goes on increasing. Now only I told you 1 shells goes on increasing. Okay, students. Now next, periods and electronic configuration. Now what is this? While going from left to right, now we will see from left to right, from from top to bottom we have seen. Okay, now while going from left to right within the period, the atomic number increases by 1 at a time. Okay, and the number of valence electrons also increases by 1 at a time. Okay, students. So if you take example, if I take this, okay, second one, if I take, see, lithium, okay, 3, beryllium, it becomes 4, okay, boron 5. So like this the atomic number increases by 1. And valence electrons also, see, lithium 1 valence electron is there, beryllium 2 valence electrons are there. Okay, students, like this. The elements with the same number of shells occupied by electrons belong to the same period. Okay, so the elements with the same number of shells, okay, occupied by the electrons belong to the same period. Okay, students, I hope till here it is clear. Okay, see, means the shell numbers, lithium 2 shells are there, beryllium 2 shells are there, boron 2 shells are there, like that. Okay, now see the next part. The elements in the second period, namely lithium, beryllium, boron, carbon, nitrogen, oxygen, then what is F? F is your fluorine. Okay, and neon have electrons in the 2 shells K and L. The elements in the third period, namely sodium, magnesium, aluminium, Si is your what, students? Silicon. Then P is your phosphorus. S is your, what is S, students? You have learnt all this. S. Then Cl is your chlorine. Yes, S is your sulfur. Ar is your argon. I hope you are also repeating after me. Okay, so all this have the electrons in the 3 shells, that is K, L and M. Okay, students, I hope it is clear to you. Yes, so we'll proceed. In the modern periodic table, electrons are filled in the same shell while going along a period from left to right. And at the beginning of the next period, a new electron shell starts filling up. Okay, means what? Here you can see, here 2 shells are only there. Okay, I am talking about this part. Neon, it is having 2 shells only, 2 and 8. But when it comes to the next period, that is starting is with sodium, it has got converted to 3 shells now. Okay, as per the electron holding capacity of the shells, 2 elements are present in the first period and 8 elements in the second period. Okay, the third period also contains only 8 elements due to the law of electron octet. You will see 8 electrons are only present. Okay, students, I hope you understood till here. Okay, so we'll proceed. Yes, now periodic trends in the modern periodic table. Now we'll see what are the periodic trends. Okay, first is the valency. All the elements in a group have the same number of electrons in the outermost shell. Okay, therefore down the group valency remains the same. Now only we saw valency of group 1 elements is 1 and that of group 2 elements is 2. Okay, so what it is said, down the group if you see, valency remains the same. Okay, students. Now the next we are going to see, that is the atomic size. Okay, the size of an atom is indicated by its radius. Yes, atomic radius is the distance between the nucleus of the atom and its outermost shell. Okay, atomic radius is expressed in the unit picometer. We write it as pm, which is smaller than the nanometers. Okay, students. So 1 pm is equal to 10 raised to minus 12 meter. Okay, so atomic size, you will remember, related with the atomic radius. And what is atomic radius, students? It is the distance between the nucleus and the outermost shell. Okay, now atomic radius goes on decreasing while going from left to right within a period. If you go from left to right, atomic radius will decrease. While going from left to right within a period, the atomic number increases. Yes, lithium was 3. Then beryllium became 4, right? So 1, 1, number is increasing, right? So the atomic number increases one by one. Yes, meaning the positive charge on the nucleus increases by 1 unit at a time. Yes, positive charge is increasing. So however, the additional electron gets added to the same outermost shell. Yes, we have seen same shell only, the electron is going on adding. Due to the increased nuclear charge, the electrons are pulled towards the nucleus to a greater extent, and thereby the size of the atom decreases. Okay, as the electrons are pulled more towards the nucleus, distance is less, therefore we say that the size of the atom decreases. Okay students, while going down a group, now when we are going left to right in a period is over, now when you go down a group, the atomic size goes on increasing. Why? This is because while going down a group, new shell is added, students. Now only you saw. Therefore, the distance between the outermost electron and the nucleus goes on increasing, because number of shells increases, distance between nucleus and the shell increases. Okay. So, as a result of this, the atomic size increases in spite of increased nuclear charge. Nuclear charge is increasing, but atomic size also increases. I hope students it's clear now. Okay. Now, metallic and non-metallic character. Next part is that. Okay. Metals show the tendency to lose electrons. Therefore, they are said to be electropositive. Why? They lose electrons. Metal give electrons and become electropositive. Okay. Non-metals show the tendency to accept electrons or share electrons with other atoms. They are said to be electronegative. Remember, important part. Okay. Across a period from left to right, metallic character decreases while non-metallic character increases. Okay, this is because the atomic size decreases due to the greater nuclear pull, which we saw now only, because of which valence electrons cannot be removed easily. And if the valence electrons cannot be moved easily, will the metal show the character, metallic character? No, it will not show. It will go on decreasing. Okay, because it will not give the electron. Okay, so down the group, metallic character increases, but when you come down the group, it will increase, and the non-metallic character decreases from top to bottom in a group. As the atomic number increases from top to bottom in a group, newer shells get added, which we have seen, which in turn increase the atomic size. We have seen now only. Thus the nuclear pull is decreasing due to the addition of the newer shells, and thus the valence electrons present in the outermost shell can be easily removed from the atom because nuclear pull is less. Okay students. So, the three types of elements can be easily shown in the modern periodic table with the help of a zigzag line. Now only we saw metalloids, they are the elements which lie along the border of the zigzag line. All the metals lie on the left, while all the non-metals, they lie on the right hand side. Okay students, I hope you understood till here. Yes. Now, this important diagram I told in the session also that yes, it is very important. If you remember this diagram, easily you can write all the trends. Okay, no need of mugging up anything. Okay, so decreasing atomic radius from where? Left to right. Increasing electronegativity and non-metallic character. Decreasing electropositivity and metallic character. It is all from the left towards the right hand side. Okay students, means along the periods and along the group from top to bottom, what it is happening? Increasing atomic radius, decreasing electronegativity and non-metallic character, increasing electropositivity and metallic character. Okay students, please study this diagram properly. You can easily write all the trends. Okay. Now, the next part is your gradation in halogen family. Now, the group 17 contains the members of the halogen families. All of them have the journal formula X2. Okay, we write it right. F2, Cl2, Br2. Okay, a gradation is observed in their physical state down the group. You can see a gradation in their whatever characteristics they have. Okay, thus fluorine and chlorine are gases. Okay, bromine is a liquid, while iodine is a solid. Okay, so in one halogen family only, whatever the elements are placed, they have the different characteristics. Okay students, so I hope You understood the part what I taught you today. The gradation in halogen family is your last topic in this chapter. Please study it properly. All the things what I taught you, again we have revised everything again. Please go through the lesson again, read the textbook. Okay students, so I'll stop here today. We'll meet in the next presentation with the next lesson. We are going to see the revision. Okay students, thank you. Saira.